Hello all. So in the last session we have seen the transfer learning technique, right? So we have seen different models of transformers. So today I would like to discuss about one important transformer model which is called as BERT. Before I actually start with BERT, let us see the language modeling history. The language model has started in 1949 before even ML era has come into existence. After that, we have so many natural models coming into picture in 20th century with multitask learning, and then with evolution of natural language processing, we have seen how word to vectors and engrams have come into picture, and then we have seen how do we process natural language text using neural networks, that is specifically using RNNs, LSTMs, and GRUs. After that, we have seen what are the disadvantages of sequence to sequence model, and how do we overcome the disadvantage with attention mechanism. And after that, with self attention, we have designed transformers, and then we have started working on applying transfer learning to the transformer models with which the pre-trained large language models have come into existence. So one such pre-trained large language model that I am going to discuss today is BERT. Okay, so this is BERT that we're going to discuss. So the entire revolution of transformers have come into picture with this concept called attention. Attention is all you need, is the paper which was developed by Google Brain, with which the concept of transformers have come into picture. So not just using the words and vector, but using the context into picture was the important parameter when designing, was the important parameter which was considered when we were designing transformers. So when we have already seen the transformer, they have encoding component and decoding component. The input is basically given to the encoder where the self-attention mechanism is applied, and the output of that is the summarized context dependent summary is given as input to the decoding component, which will convert the given input to output. So massive advantages have been observed when we compare RNN based encoder decoder architecture to transformer, right? So we can take so many tokens. Parallel processing can be done using the transformer architecture. As you can see here in the picture, we go with taking the input. Let's take translation, machine translation as an example. So I give some language in text as input, that would be given to the input embedding of the encoder block, where the positions would be assigned, because when I talk about self-attention, the inputs are generated as tokens, and the output context summary is also given as tokens, right? So the input embedding, positional encoding, we have self-attention, feed forward network, and then the output of that is given to the decoder component, where we try to decode the input data and apply that to softmax with so many output probabilities, and we try to generate the output, right? This was the transformer model that we've already seen. So when I talk about pre-trained transformer models, okay, so there are three different types of pre-trained transformer models. Few are based only on the decoder architecture, few are based only on the encoder architecture, and few are based both on encoder and decoder architecture. And the model that we're going to discuss today is BERT, which is purely based only on the encoder architecture. We don't use encoder and decoder. We use only encoder representation of the data for this transformer model, which is called as BERT. Okay, now let's see what this BERT is all about. BERT stands for bidirectional encoder representation from transformers. Let me repeat. BERT stands for bidirectional encoder representation from transformers, and this was developed by Google. It is 5-year-old. Around 2018 and 19, BERT was developed, 5 to 6 years old, and it basically understands natural language processing. It processes natural language text. Okay, and the strength of this BERT is deep learning algorithms. It is very complex, and the language it is trained is on English. Okay, so we have this another paper called as BERT pre-training of deep bidirectional transformer for language understanding. So taking this as base paper, the new language representation model called BERT was developed. Okay, so BERT is basically designed to pre-train deep bidirectional representations from unlabeled text. Okay, the data here not be labeled. Even if you have unlabeled text, we can easily train the data and get the desired results. Okay, so BERT is basically very simple yet so powerful. Okay, now let's see some important features of BERT. So when I talk about BERT, bidirectional encoded representation from transformer, it is by far the most popular, most influential, and most important and most widely used pre-trained language model, which has revolutionized how people train and build NLP models. Any model that any application that was not being worked properly or using other models, I give you a challenge. All the models that we have worked so far will work absolutely fine with this model, which is called as BERT. Okay, so it is basically a language representation model which was developed by Google. As told you earlier, it uses two steps. As it is pre-training and transfer learning, it uses two steps. One is called as pre-training and the second one is called as fine-tuning. Okay, so BERT is based on the transformer architecture. So the most important speciality or most important focus on BERT is it is pre-trained on large corpus. When I talk about large corpus, I say unlabeled text, including the entire Wikipedia, all the Wikipedia data that is existing on the internet till date is being trained by, BERT is trained by with all that data. Not only that, BERT is also trained on the entire Google book corpus, not just Wikipedia data, but also BERT is trained on entire Google book corpus. So it can give you answer for anything that you ask for. Okay, so we say BERT is deeply bidirectional, which means that it can learn information from both left to right of the tokens which I take in the input for the training. Okay, so before we actually apply BERT or before we actually come for transformers, we've learned about word embeddings, right? So word embeddings were very powerful when we have talked about NLP in the beginning. Okay, so one disadvantage or issue that we had with word embeddings was they cannot take context into account, right? So we have seen words you can use in natural language are often polysemous, meaning they have one word can have multiple meanings. For example, when I take these two words called dog and apple, usually dog is an animal, apple is a fruit, right? But if I take some sentences like hot dog and big apple, hot dog is not an animal, hot dog is food again, big apple may not be a fruit again, right? So if I take another example of the word play, they played games. This is all about playing something. I play chopping, that is music. Okay, we play baseball, live sport. Okay, and Hamlet is a play by Shakespeare. This is about drama. So the word is play, but the occurrences of these the word play has different meanings, and assigning a single vector wouldn't help much in downstreaming NLP tasks when we talk about word embeddings. Okay, and the second disadvantage, second example that I would like to discuss considering context is, let us take these two sentences. We went to the river bank. When I talk about this word river, or when I talk about this word bank, the bank, river bank is different, and the bank that we go to deposit the money is different, right? So the word here is the same, but the context is different, right? So if you want to take another example, he got bit by a python is one sentence. Python is my favorite programming language is another sentence. Python is a similar word used here, but the context here in both of them are different. So if you just get the word embeddings, it would not be enough. Okay, so word to vector is basically a context free model which will ignore the context and give you same meaning for both the words, which is Python. Okay, so due to these limitations, NLP researchers have started exploring different ways to add the context into picture, with which we have replaced the normal word embeddings with contextualized word embeddings, or simply we call it as contextualization. Okay, with these contextualized embeddings, all the occurrences of play in the previous examples would have different word vectors assigned, helping the downstream task, disambiguate between different words and the meanings which are being used in the context. Okay. Now, when we talk about the transformers that we have used, so transformer have uses a mechanism which is called as self-attention, which will gradually transform the input to the input tokens into the summary tokens, right? The core idea of BERT is simple here. It will use the transformers, the same transformers, to transform the input into contextualized embeddings here. Are you getting my point? Word embeddings we've converted into contextualized embeddings. Here when we talk about BERT, BERT takes the inputs and they transform these inputs into contextualized embeddings. That is the simple fundamental behind BERT. Okay, the transformer transforms the input through a series of layers by gradually summarizing the input, and the BERT will contextualize the input through a series of transformer encoder layers only. So that is the reason we call BERT as a encoder based transformer architecture. Okay, so here we use the concept of self-supervised learning. Okay, so the transformer which was originally proposed for machine translation is basically trained using parallel text. Okay, so its encoder and decoder are optimized to minimize the loss function, which then is applied to cross entropy to differentiate between the loss between decoder output and the expected correct translation and all that, right? But the purpose of pre-training BERT is to derive high quality contextualized embeddings. When I talk about BERT, our main funda here is to generalize or derive high quality contextualized embeddings, and therefore BERT has only encoder. Okay, now how can we train BERT so that it is useful for ground training, embedding task and all that, we will see now. Okay, so to train word embeddings, we make up a fake task where surrounding words are predicted with respect to word embeddings. We are not interested in this prediction, but rather we are interested in the byproduct of that particular training. Okay, so this type of training paradigm where data itself provides self-training signals is called as self-supervised learning, or simply we call it as self-supervision, which we apply in this particular model which is called as BERT. Okay, now with increasing larger data set and more powerful words, self-supervised learning has become very popular to pre-train NLP model for several years. Okay, the two important factors that they work here are on deep understanding of the language and how do we solve it. For example, let us take this sentence: my trip to the beach was ruined by bad dash. So not only does the system need to understand the sentence, but also it needs to be equipped with some sort of common sense to fill that particular word. When I talk about this word, bad weather may be the option, bad traffic, bad food, bad environment, bad people, all these words are correct. That fits into the sentence. Okay, so the knowledge acquired here, the knowledge required here to predict the surrounding word ranges simply from association, syntactic grammars, and etc. So all these things can be done only by the use of pre-trained language models. Hence, not just using BERT, but also we have to pre-train that BERT. Okay, so now we will understand how useful the self-supervised learning can be used for pre-training language models. That is, we will see how do we pre-train the BERT model. Okay, as already told you, BERT is basically a transformer encoder that will transform the input into series of embeddings that take context into account. Okay, so for pre-training these word embeddings, because word embeddings are the essential components, right? So we will simply predict the surrounding words based on the embeddings target, and then for pre-training unidirectional language models, we can predict the next token based on the tokens that come before the target. But for bidirectional, we can't do that. For bidirectional models like BERT, we cannot use these strategies because the input for the prediction, that is the contextualized embeddings, also depends on what comes before and after the inputs, right? So for that reason, the inventors of BERT have solved this problem with a brilliant idea called as MLM, which is called as masked language model. As you can see, they will mask few of the words randomly in a given sentence, and they let the model predict what the dropped word is. Specifically, after replacing a small percentage of words in a sentence with a special placeholder, BERT uses the transformer to encode the input, and then after that it will use the feed forward layer and then the softmax layers to derive the probability prediction of the word, possible words that can actually fill in that particular blank. Okay, so here we are using the concept of what? MLM, masked language model. Masking and predicting words is not new idea. It is closely related to the previous works that we have done. Okay, so BERT is not just trained with MLM, but is also trained with another task which is called as NSP, which is called as next sentence prediction, where we use this task where two sentences are given to the BERT model and the model is asked to predict whether the second sentence is the real next sentence of the first or not. Okay, not just NLP, MLM, but also we use NSP together. Okay, so this is how we pre-train BERT using what? MLM and NSP, masked language model and next sentence prediction. We are done with pre-training. We have done with pre-training the BERT with two tasks. Now let's see how do we adapt BERT. Okay, the second or the final stage of transfer learning, that is a pre-trained model, is adapted to the target task. Right. So there are two main ways to adapt BERT. One is fine-tuning and the second one is feature extraction. When I talk about fine tuning, the neural network will be slightly modified, where the entire network is continuously training on the training data so that the loss function would be minimized compared to the predicted output and the expected output. Okay, this is how exactly we train the neural network for NLP tasks such as sentiment analysis. We are going to see in the next session. Okay, so this way BERT will inherit fine-tuning capability to give you uh, accurate results by making BERT more powerful. Okay, so the next one is sentence prediction task. BERT uses a special token called as CLS to every sentence in the pre-training task, which it can extract the hidden states of the BERT, with which you can have different codes so that the probability distribution can give you good accurate results. Okay, so as you can see here, pre-training and fine-tuning are the tasks that we do here. Okay, so here a classification head is added in the second stage, with which you can divide the given sentence into different outputs. Okay, so another variation in fine-tuning BERT is using all embeddings. Okay, averaged over the input tokens. You can go with mean over time or bag of embeddings, where all the embedding produced by the BERT is summed up and divided by the length of input, just like bag of word model, and it can produce the output. You can go for this model by adding a classification head, or you can go for mean over time adding. So these are two different versions of BERT that you can use. Another way to adapt BERT is by using an ML model. Okay, so here the BERT is used to extract features, where a simple sequence of contextualized embeddings produced by the final layer of the BERT. We can use a machine learning model as features and make predictions also. These are the three different methods: adding classification directly with respect to softmax, or calculating the average, that is mean over time, or adding a ML model on the top. Okay, so there are more different popular versions of BERT like Albert, Robetta, Erine, and Distilbert, which are developed by different companies. Albert developed by Google, Robetta developed by Facebook. You know, enhanced representation through knowledge integration early developed by Baidu, and then Distilbert, the smallest bird, developed by Hugging Face, etc. We have so many different versions of context to vector or pre-trained bird models for video bird, visualization birds, Unicode birds, ExcelNet, Robota. So we have different variations of birds that are available in the market so far. This is all about bidirectional encoder representation from transformers, which is called as BERT. Okay, we have different parameters, different performance variations for each version of BERT. So depending on the application that we choose one version of BERT for our tasks. This is all about BERT. Thank you.